Hey, what's up, guys? So for this week, so the homework that's due not this coming week for your test, but the week after test week, is Chapter 10, which is over normal random variables. So a lot of the rules are the same with the binomial, like the binomial variables, binomial random variables. The only difference is normal random variables, they follow a continuous distribution rather than the discrete distributions we were talking about last week. Thankfully, though, normal random variables aren't that difficult. So let's do a few problems here and see maybe if this can help out with homework. Uh, Number one's probably the most annoying problem just because there's like 7 different parts. But for the most part, the remainder of these questions shouldn't be way too difficult. Just make sure that when you're doing question number one, you do every part very carefully. I'm going to do these parts with you just so we can figure it out together. Okay, so here we're given a normal distribution. The heights of adult males, they give us the mean, they give us the standard deviation, and they give us the picture of this distribution of the heights of males, and we can see that it follows a bell shape, right? It's symmetric about the middle, um, which means that it looks, if you were to cut straight down the middle and put a mirror there, uh, the right side is a mirror image of the left side and vice versa. So that means it's symmetric. It also looks like the data starts at a low value and goes all the way up to a top value and comes back down. So it looks like we have normal distribution. Of course, they already said it's a normal random variable, but you know, whatever. So here, we want to use the data that gives us the mean and the standard deviation to answer some of these questions. So here they give us the mean is 68.5 inches. So let's put that here. So 68.5. And they said the standard deviation, I think they said, was 2. Is it 2? Yeah, it's 2. Okay? So that's all pretty much that we need for this. Now, the first question they ask, what is the probability that randomly chosen male is between 66.5 and 70.5 inches tall? Use the 68, 95, 99.7 rule. They'll call it this rule, I think, mostly in this course, but it's also called the empirical rule. This is basically the empirical rule. The reason they do the 68, 95, 99.7 rule is because here is a normal distribution. Here's your mean. They say that approximately 68% of all of your data lies between the mean minus 1 standard deviation and the mean plus 1 standard deviation. We read that as within 1 standard deviation of the mean. Now, within 2 standard deviations of the mean is 95%. Within 3 is 99.7%. So that's what this 68, 95, 99.7 rule means. Alright, so here they ask us probability between 66.5 and 70.5. Alright, so remember our mean is 68.5. So it looks like basically all you have to do is find, okay, well, how many standard deviations, or how many standard deviations does it take to get from the mean to either one of these numbers? Well, we have 68.5, so if you add 2 to that, you get 70.5. So that means adding one standard deviation of 2 to this, and then take one of the standard deviations off, so the 2 again, and you get to this bottom number. So in other words, we're looking for this range of values is within 1 standard deviation of our mean. So that would be this first part right here. So in other words, it's 68%. So between these two values, and it's as simple as that. Okay, so that's the first part. Now this part's a little tougher. Okay, so let's look at this. So now we want the probability that a randomly chosen male is greater than 70.5 inches tall, and we're using the 68, 95, 99.7 rule again. Okay, so again, we remember that 70.5 was that upper value that we used before within one standard deviation. So in other words, we're basically saying, okay, well, what's the probability it's one standard deviation or greater? Okay, so let's look back here. So now this is the one standard deviation here. So we know 68% goes here, right? And then the rest of it is down here. So what we want is starting at this value and going up. Okay, so what I would suggest is, well, think of everything that's to the left of this. This is 68%, right? So then what's on this part of the tail? That's what we call this. These like little parts down here, we call this the tail. So 68% goes between these two means. So now we want to know, well, what's on the rest? So 100% minus 68% is 32%, right? So this means that there's, among adding up these two tails here, we get 32%. So if you want to find the probability of just a single tail, like we just want the probability of this one, right? Because we want to start one standard deviation above the mean and find the probability of everything greater than that. So we have to kind of think backwards. So that's why we did the 100% minus 68% to find the probability of these two tails. Well, if you just want one of the tails, divide by 2 and you'll get the other tail, because these, since we have this nice symmetry property, we can do this. So all you have to do is the 68 minus 1 minus the 68%, so that would be your 32%, and then divide that by 2, you get 16%. So then this should be 0.16. So we just used this rule. So I know it's a little tough thinking about it like that, but it's really the easiest way to think about it, because we already found the 68% in the beginning. So now we're trying to find, well, what's everything outside of this area? Because the outside of this area gives us twice this part. So divided by 2 and you get this. Okay, so now what is the z-score for a randomly chosen adult male who is 67 inches tall? Okay, so a z-score is just, it's a different way of expressing your data. So here, 67 inches tall, that is an actual data value, right? So that would be something you would find in your actual data. Well, a z-score, instead of thinking about the actual data values, it's talking about, okay, well, how far away is 67 inches from your mean? So we express the distance, so these z-scores is always the amount of standard deviations you are away from the mean. So then when you standardize your data, your mean becomes 0 and your standard deviation becomes 1. So let's actually do this. So the formula for your z-score is right here. You take your data value x, in this case the 67, subtract your mean and divide your standard deviation. So let's do that right here. So our z-score for x is equal to 67. I think it was 67. Let me double check. Yes, 67. Is simply going to be this. Type in equals, now your x value, so the 67, you go in parentheses, 67 minus your mean, so click on your mean, close parentheses because you want to do the subtraction first, then divide by your standard deviation, which is 2. So this right here is your z-score. So throw that in there. So negative 0.07, nope, negative 0.75, right? That's what we got here. Okay, so then that is the z-score. So it is 67 inches is below our mean, right? It's smaller than the mean. So this means that anytime you get a negative z-score, this means it's below the mean. When you get a positive one, it means it's above the mean. So that's kind of a nice and a neat way of figuring this out. All right. So now it says if a randomly selected adult male's height has a z-score of 2.5, how tall is he? So now we have to go backwards. So remember, this is our formula here. So now we're given it's a 2.5 z-score. Yeah, 2.5. And then our we don't have our x value, but we do have our mean, right? So it's this is going to equals your x value minus the mean, which is the 68.5, so 68.5, divided by your standard deviation, which is 2. Now, I know this looks really terrible. You don't have to do this in Excel. I have to do this so you guys can see what I'm doing, but I would write this down on paper because this is algebra right here. So it would be easier for you to do it that way. Alright, so we have a division of 2 on this side. We want to isolate our x. So multiply 2 to both sides. So we get 5, and then is equal to, now it's just x minus 68.5. Alright, so add 68.5 to both sides to get your x by itself. So then x is simply going to be your 68.5 plus 5. So 73.5. So he would be 73.5 inches tall. Okay, and that makes sense, right? Because this is z-score, a positive z-score, so this number should be greater than our mean, and our mean was 68.5. So this answer does make sense. Okay. Now here we go. Another z-score. But this time this is going to be harder. It's going to be slightly harder because they don't give us a nice z-score in our standard deviation, so we can't use our 68, 95, 97.5, 99.7 rule, or the empirical rule. We have to use an actual built-in Excel function to help us with this. So here's the problem. It says, what is the probability of the normal random variable taking a value less, so below 1.28 standard deviations below the mean? Now be very careful. This is not positive 1.8 standard deviations, and they tell you right there it's negative. This is 1.8 and then 28 standard deviations below the mean, which means this is negative 1.28 standard deviations. So our z-score is negative 1.28. Okay, so we want to find, anytime you want to find your probability, so the probability of a z-score or a data value and a normal distribution, it's really simple. It's just like the binomial distribution. I even have like a small little help part here for you guys. But since we're given a z-score, we can use our norm.s.dist. Okay, so this will give us, take a data value, or in this case a z-score, and it will find our probabilities. Should be uses z-scores. So this will find the probability given a z-score. This guy, the only difference is you use all of your actual data values, so not z-scores. Remember, z-scores is the distance away from the mean in standard deviations. But in your normal data, so without the z-scores, we're just talking about our actual data values, so you use your actual mean and your actual standard deviation. Well, in this case, it's standardized, which just means that we're working with z-scores. So you're going to use norm.s. I think of it as the s is saying for standardized, so for z-scores. Norm.s.dist, and it asks you just for your z, and then whether or not it's cumulative. Now, in this, I think most all normal stuff we do is always going to be cumulative because it's continuous. So if you do exactly equal to, you get some kind of strange answers. Okay, so what is the probability of the normal random variable taking a value less than 1.28? Okay, below the mean. So their z-score is negative 1.28 because the 1.28 z-score is below the mean. So remember, values below the mean are negatives, values above the mean are positive, and it's cumulative. Okay, so then this is our solution right here. Right, so it says you want to take a value less than this, so probability z-score is less than the z-score of negative 1.28, and we got it. So copy this guy over, paste him in here, and we'll round to 4 decimals. So 4 decimals would be, this would be 3. In case you aren't very good at rounding, that's alright. When you have the cell highlighted, you can go up here to this middle option, and these two guys increase or decrease your decimals. So if you want to do it to 4 decimals, you can do it like this. And it does the rounding for you. So see, there's 4 decimals. So you can just copy that and paste it over there. Okay, so let's keep going on. So what is the probability that the normal random variable would take a value greater than this z-score? Okay, now this is different. So in Excel, be very careful with this. When you're trying to find probability or anything using the normal distributions or any of the distributions really given built-in functions in Excel, Excel only finds the area to the left, which means that like this problem here, it only finds the probability of the stuff to the left. So what's smaller than it? If you want to find greater, you have to use complements. So if you want the area to the right, it's 1 minus the area to the left. So I'll show you how to do that in Excel. So the probability that the normal random variable will take a value greater than z equals negative 0.53. Okay, this means that this is our z-score. So we do equals. Now remember, this is greater than. Excel, by default, if I put this in there, norm.s.dist, and I put in my z-score of negative 0, so negative 0.53, if I put this in there and I put cumulative, it's all fine and dandy. It'll give me an answer. But the problem is, so here, see I hit enter, this is the area to the left, but I want the area greater than this. Now one way you can figure that out is we're saying we want the area greater than z is equal to negative 0.53. Well, remember, this means it's below the mean. So if we want a value or a probability of greater than a data value that's below the mean, it should be over 50%. Because remember, right at the mean, we have the 50% separation of data, right? So if this is below the mean and we want greater, this includes the mean. So it should be greater than 50%. So that's why this is an error. But you don't have to worry about that right off the bat when you know that you find the area to the left, 1 minus to find the area to the right. And there you go. So your answer is about 70.19%. So go ahead and put that in here. All right. Okay, so let's keep continuing on. So now for this problem, so for part 7, the probability is 87% that a randomly chosen adult male's height will be less than how many inches? Okay, so before we were given our x values or our z, right, our z-scores, and we were asked to find the probabilities. Now we're given the probability and asked to find the height. Now before we were given it in z-scores, but here you don't want it in z-scores, you want the actual data value, the actual adult male's height. So we won't use norm.s.dist at all. We'll have to use the .dist, or the norm without the s. But now, if you want to find a data value given a probability, it's not dist. You're going to be using inverse. So norm.inverse will take a probability, see right here, as an input, and then your mean and your standard deviation, and it will give you the actual data value. So here, it's 87% that a randomly chosen adult male's height will be less than how many inches. This means 87% are less than this value. So this means it's area to the left, so we don't have to worry about doing anything here. So 0.87, our mean is 68.5, and standard deviation is 2. Enter, and this is the value, so 70.75. I think they want to 10th, okay. 70.75, so that's 70.78. And there you go. Okay, so that's how you do this guy. Now, this one you guys should be able to do. This one you should be able to do as well. Alright, here, we can do this guy really fast. So here, remember, what is Q1, or our median, and Q3? Well, Q1 separates the bottom 25% from the top 75%. So in other words, 25th percentile, right? Median's 50th percentile, and then Q3, that's the 75th percentile. So we have our mean and our standard deviation, and then we want to find our Q1, median, and Q3. So let's quickly do that over here. Okay, so this is a different problem, so let me just kill all of this stuff. Okay. So again, what is our mean and our standard deviation? Okay, well, in this problem, our mean is 186 and standard deviation is 33. So 186 and 33. So now we want to find our Q1. So Q1, and then our median, and then we have our Q3. So now Q1, remember, 25th percentile. This is 50th percentile, and this is 75th percentile. Okay, so just below these guys, I'll just do one more, I guess, so that way they don't jumble up too much. Alright, so finding our Q1 is the 25th percentile, which means we want to find the data value that separates the bottom 25%. So that's simply going to be norm dot inverse. I remember we want the actual data value, so we got to use inverse. If we wanted the z-score, we would use norm dot s dot inverse, but we want the data value, the actual percentile. Okay, now probability, if it's the 25th percentile, it's going to be 0.25. Our mean is 186, so I just click on it, and then our standard deviation is 33, so I just click on that as well. And there we go, 163.74 stuff, and that's what I put in there. Okay, now let's keep going on. Let's find our median. Now, you can use two different ways to figure this out. The median is the exact 50% value, percentile. Now, if we're talking about normally distributed data, we already know what our median is going to be. It's going to be equal to the mean. If the data value is exactly normally distributed, which they say is normal follows a normal distribution, then our median is just going to be 186. Now you can check it just to make sure. Okay, so you're like, oh, well, I don't remember what the median does. All I know is it's the 50th percentile. So then you can actually just type it out anyway. Norm dot inverse. Okay, your probability is 0.5, it's 50%. Your mean and your standard deviation. Enter. And it's 186. So your mean and your median in a normal distribution are equal. Okay, so now Q3, do the exact same thing, norm dot inverse. Your probability now is 75%, so 0.75. Click on your mean and your standard deviation yet again, and you get the actual data value, the 208 about. There you go, you throw it on there and you're good. Alright, last problem. So here, suppose the height in inches of U.S. women over 20 years of age is a normal random variable with mean mu is equal to 63.8 and standard deviation is 3.2, so sigma 3.2. What proportion of U.S. women are between 5 and 5.5 feet tall? Ooh, okay. So this guy right here, this is a little more tricky. So let's check this out. Alright, so we want the probability of this, right? So probability that our x value is between 5 and 5.5 feet. So this is in feet. But now be very careful not to continue the problem this way. It's trying to trick you. It says we want the height in inches. So we have to convert these 5 and 5.5 feet to inches, respectively. So that's done pretty simply, right? We just have to, there's 12 inches in a foot, so it would just be equals 5 times 12, so it would be 60. So probability 60 less than x. Now we just got to find our upper bound part, so that'll be over here. So now it's 5.5 times 60, or 12, sorry, 66. Alright, so then we want the probability that x is between 60 and 66 inches, and this is in inches. Okay, so now this can get kind of tricky. So we want to find the probability in between. Anytime you want to find the probability in between, so prob in between, you have to find prob left of 60 and prob left of 66. So you find the probabilities to the left of 60 and the left of 66. So in other words, less than 60 and less than 66. Then you subtract the two. So you subtract the smaller prob from the bigger one. That's simply how it goes. So that's pretty much how we do this problem. So let's see here. Let's find a probability that x is less than 60 first. Then we'll find the probability x is less than 66. Alright. So here, 60 is an actual data value, so it's not a z-score. Z-scores would be much, much smaller, right? 60 is the actual height, so we're using actual data values, so we're going to use norm.dist, not norm.s.dist. Remember, we only do that when our mean is 0 and standard deviation is 1, but for here, we have to use our means and standard deviations that they give us. And actually, let me change these really fast, because these are not the correct ones. So, the mean, they say, is 63.8. So mean is 63.8. And then our standard deviation is 3.2. Okay, so there we go. Now we can do this. So equals norm.dist. All right, now our x value that we want to find the value less than is 60. So type in 60. Okay, now your mean is the 63.8, comma, your standard deviation, so click on that. And when you're working in norm, you're almost always going to have cumulative, so just type a 1 for yes. Okay, so there you go. That's less than 60. Now let's find this other guy. So norm.dist, and now it's not 60, it's 66. Our mean is 63.8. Standard deviation is 3.2, and it's cumulative. Okay, now remember, to find the area in between, or the probability in between, you subtract the smaller probability from the bigger one. So the probability, or just this guy, so this guy is simply, you take your larger one, the 75% is bigger than 11%, right? So we start with this one, minus the 11%. There you go, 63-ish percent. And that's exactly what we got here. All right, so that's how you do this problem. I know it can be kind of confusing trying to figure out when you're going to use norm.s.dist and norm.dist. So if you confuse those two, and of course even some of the inverses, check out my I uploaded a helpful Excel sheet in your iCollege, and with some examples. You guys can check that out if that helps. But yeah, knowing the difference of how to find area to the right as opposed to the left, so knowing how to do complements and knowing how to find probability or area in between is very important. So make sure you guys know how to do this fairly well. But I hope this video has helped. If you have any questions, feel free to email me or meet with me during my office during office hours. Thank you.